Okay, my algebra doing friends, this is 9.3, more solving on quadratics. Actually, these equations aren't quadratic, but you can convert them into quadratic and solve them. So it's a little practice on substitution, something that's going to be huge in calculus. And so this is just a little bit of practicing it here. So I'm often asked, I know a way of doing it without substitution, without using substitution. And so can I do that instead? And my answer is you ought to practice the substitution so that when you get two problems where you can't use substitution, you've had a little practice at it. And so maybe do it both ways just to see, because I always kind of feel like you should do everything the easiest way possible. But here, the substitution is kind of a tricky step, and so I really feel like it would be really nice if you gave a practice to it. So the first thing is to look at what would be the standard quadratic form, and so that's what they say is step one. I got the steps right out of your book this time, so if you're wondering, hey, that's not how yours usually look, you're right. And so what they mean by that for step one is see how this is in descending order with 0 on one side? Well, they mean I want this to look like something squared minus 17 times the something plus 16. That's the standard quadratic form. And if I can put in both places here the same thing, so here I had x squared, if you can put in x squared right here and it still be true, it's quadratic in nature. And so, and you notice that is true, right? Because x to the second raised to the second is x to the fourth. So then what they say to do is replace these two x to the seconds that we put there with u. And so this would now look like u squared minus 17u plus 16 equals 0. And you could give this to anyone and ask them to solve it, and they would say it's quadratic. So right here, it was degree 4. And I did a little bit of a substitution. I substituted u for x to the second, right? I replaced x to the second with u, and now it is quadratic. And on quadratic, I have 3 different methods that I can solve it with. I have the square root method, I have factoring, I have the quadratic formula, and I, of course, could complete the square, but it's not my favorite method. So I'm not even going to put the completing the square as an option for myself here. Completing the square and the quadratic formula will solve all of them. So if I'm going to use something that'll solve all of them, I'll use the quadratic formula. So the square root method is not appropriate on this one because it has the middle term, so I'm going to drop it out. Factoring could be appropriate because I'm kind of looking at that and I'm thinking, hey, that could be 1 times 16, and that would add to be 17. And in fact, they both have to be negative in order to add to 17. So this is going to be u minus 1 times u minus 16 equals 0. So now I'm on solve normally for this quadratic. So set the pieces equal to 0. So u minus 1 equals 0, or u minus 16 equals 0. So adding 1 to both sides, u is 1 and u is 16, right? But no one cares about u. And so after you do your substitution like this, you have to substitute back. And so I know this is awful, but no one cares about you. Not you, everyone loves you. No one cares about the variable u, right? They want to know about x. Not your x. They want to know about x, right? And so what we remember is that u was the same as x squared. So this is x squared equals 1. And so I'm replacing u with x squared. And then now this is another quadratic to solve, right? So as I substitute back in, I'm getting another quadratic. Now this quadratic, so I'm back to quadratic, right? Square root method. And this one's perfect for the square root method. I have something squared equals a number. So you remember how you solve using the square root method? You have x squared equals k. So you can write that as x equals plus or minus the square root of k. And so in this case, that's going to be x equals plus or minus the square root of 1. X equals plus or minus 1. So there's two answers there. I'm going to do the same thing here. I'm going to drop back to x. From u, I'm going to drop back to x. So this is x squared equals 16. So that x equals, using the property, x equals plus or minus the square root of 16. So that x equals plus or minus 4. So altogether, I have 4 answers, which is how many answers you would expect from something that is degree 4. 4 answers, right? And if I didn't have 4 answers, it would be because there was repeats. And I could certainly check, and it's always a good idea to check. So I could check these one at a time. So good idea to check. So you would be here going, what to the 4th minus 17, what to the 2nd plus 16 equals 0. And I would check these one at a time. So like, for example, I could check 1. So I'm going to have my parentheses here, 1, because that was one of my answers, raised to the 4th, minus 17 times 1, raised to the 2nd, plus 16. And I'm expecting that would be 0, and it is. Now I had also negative 1, so I could go change that 1 into a negative 1. Negative. And it's 0 as well. And I could go change this 1 into a negative 4, because my other two answers were plus and minus 4, right? So I'll do negative 4, 0. And my other answer, my last answer, was just plain old 4, positive 4. And so I'll delete off of that. So I know that there's some people that would tell me that, hey, I think I could have factored this from the beginning and got these answers. It would have been a little bit less work. And I'm like, yes, give it a try. But we were practicing our substitution. And so that's the reason that I went ahead and did it using substitution. Okay. We solve these problems here in this example. I think these problems came out right out of your book. I don't know why I don't have them numbered. I have this one numbered, anyway, we solve problems like this in chapter 8. And what we said to do was isolate the square root, get the square root all by itself. And so this is giving you another way of solving that. And that is first to write out the quadratic form, which is something squared minus 4 times that something minus 1 equals 0. And then see if you can make it be the same. And it's always the middle term that tells you what it's going to be. So this is the square root of s in here. So can this be the square root of s here and still be equal to s right there? And I want to investigate that a little bit bigger and not muck up my work right here. So I want to investigate the square root of s squared. And remember that the square root of s, I don't know if you guys remember, I hope you remember, is equal to the square root of s is s to the half. So this is s raised to the half. That's what the square root of s is by a definition we had in chapter 8.1, right? And then when you multiply these together, half times 2 is s to the 1. And hey, that's what that is, s to the 1. And then what you're going to do is you're going to replace both of these square root of s's with u. U equals the square root of s. So this is going to look like u squared minus 4u minus 1 equals 0. And then I'm going to give a solve to that. And So it was square root, right? And we had a way of solving a problem that had a square root in it. But we've just been given another way, and that's to use the U substitution. And now it's quadratic. So that U substitution turns it into quadratic. And now that it's quadratic, I can use the square root method. These are my methods. I can factor. But of course, you can only use the square root method if you have the missing middle term, but I don't. You can only factor it if it'll factor, but this won't factor, right? 1 times 1 is the only way of making 1, and that's not going to make a 4 in the center when you're subtracting. So I have to use the quadratic formula. And so I really don't have a choice, but that's what I think whenever I have quadratic. Okay, so my A is 1, my B is -4, and my C is -1. And my formula looks like U equals, and then it's negative of B plus or minus B squared minus 4 times A times C. I haven't broken into singing Pop Goes the Weasel here yet, right? And then over 2A. And I'm going to be filling in here for B, -4, here for B, -4, here for A, 1, here for C, -1, and here for A, 1. And I want to simplify this. So this is U is going to equal 4 plus or minus, and then underneath here I have 16 plus 4. And 16 plus 4 is 20, right? And you can put this in your calculator underneath. So this is 20 over 2. Now 20, I've done 20 so many times. The square root of 20 is 2 times 2 times 5, which is 2 times the square root of 5. So this is U equals 4 plus or minus 2 times the square root of 5 over 2. I'm going to have to make a note to have more room. And remember the triangle that I was telling you about? I call it the Moretti triangle because that's what my teacher, Mr. Moretti, called it. They all have in common 2, so I can divide out a 2 from all of them. So this is 4 divided by 2 is 2, plus or minus 2 divided by 2 is 1, square root of 5, over 2 divided by 2 is 1. And then it's not necessary to write this 1 because 1 times the square root of 5 is the square root of 5. And so this would be 2 plus or minus the square root of 5. And then it's not required to write that 1 because whatever divided by 1 is the whatever. So this is our values for U, and I'm totally out of room, and I'm going to make myself a note to add more room to this problem. And I apologize about that. Probably should have had a whole page for it. So U equals 2 plus the square root of 5, or U equals 2 minus the square root of 5. Okay, and we've got to solve for x, and so we're gonna do that. 5's and s's aren't going very well together. U equals the square root of s, right? And so here 2 plus the square root of 5. Now the square root of 5, when I put this in here, for U, the square root of s. And remember, whenever you solve a square root problem, you have to make sure that this side over here, you have to pause and make sure, is it positive, is it negative, or is it a variable? And so over here, this is not a variable. 2 plus the square root of 5. 2 plus the square root of 5 plus the square root of 5, just so that you could see, s to d is a positive number. And so since it's a positive number, then all you have to do is square both sides and you'll get the answer. So this is going to be the square root of s squared and 2 plus the square root of 5 squared. And they had me practicing squaring that kind of, this is s here, right? So that's my answer. And they had me practicing squaring stuff like this in chapter 8. 2 plus the square root of 5 times 2 plus the square root of 5. So 2 times 2 is 4. 2 square roots of 5, more 2 square roots of 5, another one, and last but not least, the square root of 5 times the square root of 5. I'm going to go ahead and write that. When I do that is the square root of 25, which is 5. And then 5 plus 4 is 9, plus 4 square roots of 5. There's my answer, and you always ought to check your answer every single time. Let me see if I can find the other answer. So I've kind of got into this, oh yeah, I definitely need more room here. I'm like feeling really, 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 really bad about it. When I say that in a video, I get about 2 people that tell me, oh, you're okay. So thank you. 2 minus the square root of 5. And I just want to show you that's negative. And so this equals over here, remember we were going to pause and look at what it was, it's negative. When the square root equals a negative, that means there's no solution. Now we already got this as a solution, but this is not going to lead us to a solution here. And so I'm grateful about that. Now I want to check my answer. And so when I check my answer, I'm going to check back here in the original, and I want to show you a way of checking that I've showed you before, I know, in class, but it's kind of clever. I'm going to put in 9 plus 4 square roots of 5. And that's the last thing I've had in. So that's my answer. And so when I go to check this, I'm going to here, s minus 4 square root of s plus minus 1 equals 0. So that here I am up here checking. What I'm going to put in here is the answer. Minus 4 square root of the answer minus 1 equals 0, because this is what I have in for the answer, and then that would be a little less plugging in. So I'm going to have the answer. So I push down here, answer, minus 4 square root of the answer, and then I want to go outside, minus 1, and I did get outside there, and that ought to equal 0, and it does. So I know that this is a good answer. Good idea to always check. Okay, and so that one spilled over into everywhere. And this is just a remember that the square root is not equal to a negative number. So that remember when we solve that over there, just a note on that. Okay, one more to solve here, number 16 from your book. And they're wanting us to look at this as quadratic in form. So we're giving a practice to that. There are other ways of solving it. Likely there's 4 answers. I want to try to find all 4 of those answers. And so what I'm thinking this is going to be looking like is 25 raised to the second minus 9 equals 0. So that it's quadratic, right? And what would go in here? Well, what would go in here is x to the second. So that's what I ought to let, we have the missing middle term here, that's what I ought to let u be. So this will be 25 u to the second minus 9 equals 0. And I can use either factoring to solve this or the quadratic formula, not the quadratic formula, I don't want to use that, or the square root method, my choice. And so here it was degree 4, which means I'm expecting 4 solutions. And here it is degree 2. I've changed it by doing the substitution. And I'm going to find 2 solutions for u. Then I'll use those two solutions for u to find some more solutions for x, right? So that's kind of the idea. And so since this is quadratic, and that's what their goal is on these, is for you to use a u substitution to turn it into quadratic. Sometimes I ask that just as a question on the test, just to put this and then to stop. Just turn it in, use a u substitution to turn it into an equivalent that is quadratic. Okay, so now, and of course they ask you to do the whole thing in the book. So now I could use the square root method, I could use factoring, or I could use the quadratic formula. And actually on this one, I could do any one of those 3. all three of those will work. This works on every single equation. This happens to factor here because it's a difference of squares. And the square root method will work on this because it has the missing middle term. I'm going to use the square root method because it's my favorite method when it'll work. So 25u squared, I'm going to add 9 to both sides because you get u squared all by itself when you use the square root method. I'm going to divide by 25. So I have u squared equals 9 over 25. Now I'm going to use that square root method that says this is my k, right? And this is going to be u equals plus or minus the square root of your k. Has to be a constant. And the square root of 9 over 25 is 3 over 5. So u equals positive or negative 3 over 5. So I'm going to turn this back in. So u equals 3 over 5 or u equals negative 3 over 5. And I'm going to turn this back into x's. So remember we said that u was x squared. So that's what we're saying here. Replace for x squared u. So here, replace x squared for u to go back to x's. So x squared equals 3 over 5. Well, it's another square root one where I can use the square root property, right? And so this is going to be k equals plus or minus the square root of 3/5. And they would want us to simplify that answer. And I'm going to run out of room on this paper, this one too. Yeah, I'm feeling really bad. I'm writing more room, like double, right? More room. Might be a good experience for me. Even the other one, we kind of made it on the other one, but okay, so I'm just going to add some paper to go on here. So this is x equals plus or minus the square root of 3 over the square root of 5. And then you match it. You multiply by the square root of 5 over the square root of 5. And that'll get rid of the square root that's in the denominator. So this will become x equals plus or minus the square root of 15. And this is the square root of 25, which is 5. And then that's 2 answers right there for x. Remember, we were expecting 4 answers for x. So there's 2 answers right for x. I almost made it on my paper there. I know it needs more room, but I mean, I'm just a little tiny bandage here. More room. Okay, so here, replacing u with x squared, so we'll get x squared equals negative 3/5. Then doing the square root property, we'll get x equals plus or minus the square root of negative 3/5. Then you can pull out the I, so we'll get x equals plus or minus I times the square root of 3/5. And then the square root of 3/5 is what we just simplified here to be the square root of 15 over 5. So I'm not going to waste any time. I'm just going to go right to it. So plus or minus I times the square root of 15 over 5. And depending on the book that you're using, they'll write the I first or they'll write the I last. So I'm good with either. So you could write it like this. And that would be wonderful. Those are 2 more answers. These 2 answers were real. These 2 answers are imaginary. People always say, well, if it's imaginary, that means it never comes up in real life. But they do. And so it got kind of a bad name. And so just like improper fraction got a little bit of a bad name. And it was, as it was being developed, they didn't see the real world applications of it. And now they do. And so anyway, my friends, that's the video for today. We'll also have up for you guys to do some problems. And I'll see you later, alligators.